taking a look at a website. I want to go on now to talk about making a controller or a video game controller or something like that. Now, it's not possible on an Arduino Uno, and it's certainly a little bit difficult using Tinkercad, but we're going to achieve something that's very similar. So, what does a game controller need? Well, of course it's going to need buttons. But it also needs a microchip inside of it to be able to interpret all the button presses and know what to do with them. So, for the chip, we're going to use an Arduino again. So I'm going to type in Arduino. I'm going to grab that, and I'm going to stick it down, and I'm going to rotate it around a bit. There we are. Right. What else do we need? We need lots of buttons, but we need really to put them on something, just to make it easier to work with and easier to manage. I mean, you could have loads of buttons just floating around, but that would be awful. That would be quite painful to use. I mean, it would just turn your PlayStation 4 controller into a mess of wires, and no one wants that. So what we are going to do instead is we're going to use a piece of breadboard. Now, no one really knows why it's called breadboard, but all breadboard is like a circuit board that you don't have to solder components onto. Usually you have to get a very hot iron and you have to melt the components onto a circuit board. But a breadboard is different. It allows you to just push the components into certain holes and the components will stay there. So in this search bar, if you search for bread, usually the first one that comes up is breadboard small, and that's the one that you want. So I'm going to click that, and I'm going to drop it in, and I'm going to rotate it around so it's easy to see the columns and rows. So what is a breadboard? Well, a breadboard essentially just carries electricity for you, and it has lots of holes where you can push components into them. And the first thing that anyone should do with a breadboard is they should make sure that this column is wired up to positive and this column is wired up to negative. So what am I going to do for that? Well, I'm going to start by looking over in this collection of pins on the left hand side of the Arduino. I'm going to click on ground, GND, and I'm going to make a negative wire. I'm going to have it coming across like that, and I'm going to plug it into the negative column. I haven't clicked yet, but as you can see, every single one of those has a green circle around it now. And the green circles are showing you what's connected to what. So as soon as I plug a wire into the top one here, the electricity is carried through all of them to the bottom. So let's click. So now that whole column has become exactly like this negative ground pin here. And just so that we know it's negative, I'm going to click on this wire and change it to black. Okay. Now we need to do the same for the red. So I'm going to find the pin here called 5 volts, 5V. I'm going to click on it and I'm going to draw it around. Yours doesn't have to be neat at all, but I really like making it neat. I'm going to plug it into the positive now. So now we can see that the positive is all connected from top to bottom. Let's make that red so we know what it is. So before you move on to do anything, you should have a circuit that looks like that. Right, so what do we need to do? Well, a button needs a couple of things to get it to work. But the first thing it needs, of course, is it needs a button itself. So I'm going to type in the search bar, button. What am I doing? I'm in numpty. It's right at the top. It's called push button. So when I'm going to drop it off here in empty space, and we can see that it has 4 pins. Now we need to get this to fit into our breadboard. So I need to make it that the pins are going from side to side. At the moment they're facing top and bottom. So basically I need to rotate this button around 90 degrees. So make sure it's clicked. And I'm going to press this rotate button in the top left hand corner. There we are. And now we can actually get on and control it. We need to plug this into our breadboard. So I'm going to grab the button and I'm going to bring it down and drag it, and I'm going to make sure that it actually snaps into the holes, and I want it going in this gap between the columns, between the 2 sections. There we are. So, yeah, as we can see, this part, this bit is connected to this pin, and this bit, this row, is connected to this pin. So on a breadboard, if it's the plus and or minus column, the electricity flows top to bottom, and for the rest, it flows from side to side. So from left to right. So if something is plugged into row 22, then if there is another component plugged into row 22, it'll get the same electricity. But it doesn't cross over this gap down the middle. That is, unless you've put a button in the way, which I have just done. But let's move on from that. What I need to do now is I need to wire up one side to the positive. So let's do that. Let's choose this pin down here. So remember that it's everything in this row is connected, everything in row 29. So I'm going to choose one of the bits from row 29, one of the holes, and I've now clicked it to start a wire, and I'm going to finish it in the positive column. And because that's positive, let's make that red so we can double check. There we are. And it's a bit hard to see because it actually crosses over, but it's only connecting the positive column and one of the pins in row 29. So now at least half of this button is wired up to the positive. And I need to now wire up the negative. But there's an added difficulty. I need to put a resistor in the way. So let's search for a resistor. Resistor. And what I'm going to do is I'm going to put one end of the resistor next to the button in row 27. And then I'm going to look at the other end of the resistor and I'm going to connect that row to the negative. So let's move that across and let's change that to black. Okay, so we are now halfway done with our button. Let's take a breather and check what on earth we're actually doing. So we press start and electricity comes in through this USB and into the Arduino. Then it goes into this red wire here, follows all the way along, and into this positive column here. It carries on down the column until it gets to this wire here. And it travels along this wire, and then it travels along this row of the breadboard and into the button. Now, it goes through the button and out again, and into this row of the breadboard, and then from this row into the resistor, and it goes up the resistor into row 22. Sorry, my mistake, row 23. And then it goes from row 23 into the negative column. It goes up the negative column, through the negative wire, and into the ground at the Arduino. And that's all sorted. We've technically wired up a circuit, but our circuit has no way of sensing when the button is pressed. So we're going to build that next. And to do that, I'm going to stick a wire on the other side of the button. I'm going to have that wire come out. And I'm going to have it come down. And I'm going to choose one of the pins on the right hand side for it to pop into. Let's say pin 6. So now pin 6 is going to detect whether or not our button has been pressed. But that's not going to work. We need to write our code for that as well. So I'm going to go over to code. And this whole thing, I'm going to move into the bin. This is the code that was already made for me. I don't want that. Now, what I want to happen is if somebody presses that button, something happens. So the first thing I'm going to need is an if. So I'm going to go into control, and I'm going to find if. So if something happens, do something. What is that something? Well, I need to check what is the value of pin 6. And remember that the pins on the right can only be high or low. When the button is pressed, that pin ends up high. So I need to check whether that pin is high. So this is a diamond block in the if. So I'm going to go into maths. And I'm going to grab this diamond block here. If something is something, then something. What I want is the value of pin 6 equal to whatever high is. So I'm going to change that to an equals. And on the right hand side, I want the high. So the high is already down there for us. So I'm going to grab that and stick it in there. If something is high, is pin 6 high? Well, I need to check pin 6. So if I go to input, I've got several options. I've got read digital pin or read analog pin. If we look down on the board itself, we can see that everything on the right hand side is digital. So I want to read the digital pin. And which pin do I want to read? Well, I want to read pin 6. There we are. So if pin 6 is high, do something. Well, what can I do? Can't really do much for now, so I'm just going to have it output to the serial monitor, just so I can see what's going on. So to do that, we can go to output. And there is this option down here, print to serial monitor. And I'm going to put that in there. And instead of saying hello world, I'm going to say button pressed. Now, let's see if that works. So I'm going to click Start Simulation. I'm going to open the serial monitor by clicking on it. And here's the grand test. When I click this button, I should have a message pop up in the serial monitor saying button pressed. Let's try it. Yeah, we've got it. There it works. I hold it down and it carries on printing lots of them. I let go and it stops printing them. And there we have it. So, believe it or not, that is essentially exactly what happens in any PlayStation or Xbox or any controller like that, or even the keys on your keyboard, or most importantly, the keys on medical equipment. Any button you see in life works exactly like that button does. So let's have that button do something. Let's have it so it, I don't know, lights up an LED. So I'm going to click Stop Simulation, and I'm going to minimize the code, and I'm going to search for an LED, because that's what I want. And we want this one here. I'm going to plonk it down, and it's much easier if this is rotated 90 degrees. So let's rotate that. There we are. So what can I do with this? Well, I need to stick this into the breadboard. So I'm going to stick it in. I'm going to grab it. I'm going to stick it, let's say, there. Righto. What can I do now? What we looked at previously was we know it needs a resistor, otherwise it's going to blow up. So let's stick a resistor in. So I'm going to search for a resistor. There's the resistor. It's currently in the wrong orientation. I need it turned around. So I'm going to click on it and I'm going to click rotate. I've pressed rotate too many times. Ugh, silly me. But there we are. It's rotated, so it's horizontal now. I'm going to drag it in so that it connects the row with the LED top leg on with this row 7 over here. And this gets connected to the negative. So next to the left hand leg of the resistor, I'm going to draw a wire to the negative. So now, whatever comes into the LED goes through the LED, through the resistor, and into the negative. Now I need to connect the other side of the LED to something that's going to make it light up. So I'm going to connect it to one of the pins. So I'm going to connect this one to, let's choose a pin. Let's choose pin 10. And let's make that, pick a color. Let's make that purple, yeah. So now I've got a wire going from pin 10 to the LED and then through the LED to the negative. So it's completing a circuit. So what we're going to be able to do is in our code, we'll be able to tell pin 10 to switch on, which will then send electricity to the LED, which should light up. Unless I've wired it backwards, which when it comes to LEDs is so easy to do. So over in code, I've got this: if we press the button, we print to the serial monitor. Well, if instead of just doing that, we also set pin 10 to high. So over in output, there is this set pin block. And rather than set pin 0, I want to set pin 10 to high. And let's close the code and let's start the simulation. So, fingers crossed, when I press on this button, it should light up the LED. Let's see. And there we are. It lights up the LED. And as soon as I let go, oh, It's just turned it on. We've made a light switch. It's not what I was hoping to do, but there's a way around that. So we've got it so that when we press the light switch on, it turns on the light, and now we need it so that when we let go, it switches off the light. So let's stop simulation, and let's go to code. So at the moment we've got if it's read as high, let's make that bigger. If it is read as high, then switch it on. But I want to have it as if it's read as a low, switch it off. So what I really need to do is I need to replace this if block with something else. So I'm going to go to control, and we need the if then else block. So I'm going to grab that out, and I'm going to put it separate, and what I'm going to do is transfer what I do have over to it. So we're going to steal this bit here. We're going to steal these two bits and put it in the top half. And now we can get rid of this old if. So if the button is pressed, switch it on. But if the button isn't pressed, switch it off. So output. Set pin 0 to, well, let's grab that and let's change that to pin 10 first of all. And rather than having it as high, we're going to have that as low. Let's see if that works. I'm going to minimize the code and press start simulation. And let's press the button now. That lights up our LED. Let's let go. And there we are. It turns off. Let's try again. Switch it on. Switch it off. So brilliant. There we are. We've pretty much got that sorted. So what can I do next? How can I expand on this? Well, as long as you like, see if you can add a couple of new buttons and get those buttons to do different things. I've already shown you how to do one button. I'm going to start showing you how to do another one. And it's exactly the same as we do the first one. We just change which pins. So I'm going to grab a push button. I'm going to rotate it 90 degrees. I'm going to put it in the circuit so that it doesn't interfere with anything else. So it's on its own set of rows. I'm going to have the bottom connected to positive. Then I need a resistor. And I need to connect the resistor to negative. And now I need to connect the top right pin to one of the reading pins on the right. Let's choose pin 2 for this one. So now I have button 2 on pin 2 and button 1 on pin 6. And now if I go into code, I could change that to pin 2 if I wanted, or I could have pin 2 do something else. I can do whatever I like with it. I could maybe have it so that when I press pin 2, it switches on a motor. Or when I press pin 2, it, I don't know, makes a noise. In fact, if I click on code again, when you're looking through this components list, if I click on components, we can see this bottom section called starters. And these are examples, and it will show you examples of how to get things working. So if I click all, we can see that we've got a tilt sensor, we've got blink a LED, we've got analog input, we've got servo. So a servo is how you can make motors move, that kind of thing. We've got tone melody, tone pitch. Neopixels are great fun. I've got a set myself. Read analog voltage, and so on. Blink without delay. Tone keyboard is good. Let's just load up the tone keyboard for fun. It takes a little while. Oh. Whoops. Yeah, delete that. That was a bit of a disaster. Let me try again. Tone keyboard. Let's just stick it there. I'm going to go into code. And yeah, that's the code for the tone keyboard. Let's start the simulation. There you are. And let's stop the simulation. So there's plenty of things that can be done with Arduino. And as I said at the start, the only way is to explore. So anyway, I hope that's been fun. And yeah, have a lovely week and stay safe.